How about now? Can you hear me? Yay.
First few rows.
How about you guys in the back? Can you hear me all right? Yay. All right. We're all set then. We are ready for another edition of All Space Considered. I'm Dr. Laura Danley. I'm the curator of Griffith Observatory and your host for tonight. Next to me is Patrick So, our Astronomical Theater Programs Manager, and Tony Cook, our Astronomical Observer. And sitting somewhere is Dr. David Weintraub, our Astronomical Lecturer. He's just not in this chair because we're going to put someone else in this chair for a few minutes tonight. It's a shock. I know. So he graciously gave up his chair. So thank you, David. And you have come into All Space Considered. How many of you have been to All Space Considered before? Yay. How many of you have never been to All Space Considered before? I always swear that looks like more. All right, is anybody raising your hand twice? Okay. For you people who have not come before, I'm interested in how you got here. So how many of you came here because a friend brought you? Okay. Not many friends. I mean, those of you who didn't raise your, you know what I mean.
Oh, wow. Hard.
Ouch, I'm sorry, and it's August and everything. I am sorry if I offended anybody. I really didn't mean that to be offensive. And how many of you came because you saw it on a website? Any website? And what's a website? And how many of you saw it in a print newspaper? Yeah, there you go. What's a book? What's a newspaper? How many of you are, what am I running out of? How many of you are here because you saw a line and you got in it? Okay. So what am I missing? For the rest of you didn't answer any of those. How did you end up here tonight?
We've been coming for a long time.
Oh, I mean of the people who are here for the first time.
We know Dr. Weintraub.
Hey.
Oh, you brought a fan club. Excellent. Okay, wonderful. Okay, well, with that, let me then introduce and get on with the show because we want to get to Dr. Weintraub. I guess everybody now knows our guest is sitting over there. So let me just say a few quick announcements to make this evening go smoothly. We will be taking a break in about an hour, and so if you need to leave before break, you have to climb over everybody and go to the back of the room. Don't go that way. That's actually a closet. And although it is fun to watch people sheepishly come back and try to go up the stairs unnoticed, we all notice you, and so you don't want to go there. That is an emergency exit, and if there is an emergency, we will lead you out through it, but it is not to be navigated by the faint of heart all by yourself, you know, unless you've said your goodbyes to your family. So we will take you through it if we need to, but other than that, you know, go out the back. And then if you have a cell phone, I recommend you turn it off. You will not get any reception in here because of this lovely grating that surrounds the whole room. So no reception comes in here, so you'll just waste battery roaming, looking for a signal, and you'll come out and you'll have no battery to get your Lyft or your Uber, so that would be bad. And then lastly, does anybody have any Planetarium show tickets for tonight? So great. So you're all here. We won't worry about getting people out in time for that. Other than songs and swag, is there anything I've forgotten?
Photo.
Thank you so much. How many of you have members of Friends of the Observatory? How many of you just joined Friends of the Observatory on Monday because you came up here and you wanted to join? Okay, well, you can think about joining if you're not a member. And how many of you are tax-paying citizens in the city of Los Angeles? Yay, tax-paying citizens of the city of Los Angeles, because we are city-owned and operated. Department of Recreation and Parks is our home. And, you know, not a lot of cities pay for and support a municipal observatory. So we are your public observatory here to bring astronomy to you, your family, your friends, your loved ones. So we're just very glad that you're here tonight, and we thank the city of Los Angeles and its tax-paying citizens for making all of this possible. Okay, so with that said, Bill, you want to tell us what have we got going tonight?
We have. Hi. We have an amazing game we play every time we do this show. I've given it several names, but it basically is we were playing music as you were sitting down. Every piece of music that you heard is connected to one of the stories in the show, and it is quite all right to, when that story comes up during the course of the show, to shout out the name of the song or you know, some identifying feature of the song if you don't know the exact title, and then you win a prize. And if you do this in the first half, you come down here at intermission, you get one of these prizes, and if you do it in the second half, you come down at the end of the show. We have all kinds of great stuff here. We have bookmarks and stickers from missions. We have actually a couple of packets from NASA, NASA's Journey to Mars. I was just handed these. They're hot off the press. I haven't even looked at them yet, but they look very interesting.
Oh, look inside. There's a pin.
Oh my goodness,
Yeah.
there is a pin.
So you get pictures,
an insight
stickers.
Pin. You want this. So remember the music. Pins, man, come on. They're almost as good as patches, but they're better than patches. We also have these. These are great, I think, for kids. They'd be a great, you know, stocking stuffer or some kind of birthday present or something. They're stickers of all the major solar system objects. We have a flashlight that doesn't really work. And the best part is we have these Griffith Observatory calendars for 2015, 2016, and 2017. And everybody laughs at me when I say, you know, they're all out of date, but they're beautifully produced. They're all about Griffith Observatory, and you can use them again. The 2015 will be good again in 2026. It's not funny, it's true. 2016 will be good in 2044, so you got to be patient with that one, and 2017 and 2023. So stick them in a drawer, put a reminder in your phone, and you're done. That's it. Take it away.
Great. So I forgot to say welcome to our live stream audience. Sorry you're not with us in person, but we're glad you're here online, and I hope you enjoy the show. So we're just going to jump right to it. As this indicates, we run All Space Considered on the first Friday of every month. And today is August 3rd. I keep thinking it's August 6th, but it's not. It's August 3rd. So tonight we have in store for you, in the first half, the obligatory rocket launch. And then this park is lit, which is really a terrible thing to say about the fire that we had. As you know, this comes from some of our staff come up with these lovely names. The August Sky Report, not as big as the moon. I think you might know what that is. And then Mars, Water Underground. And with that, we will introduce our wonderful guest, Dr. David Weintraub, who I guess you've already seen, sitting over there, ready to join us at the correct moment. And then after David's presentation, we will have pretty pics, as we always do, pretty pictures. And then we will take a break. And this break is going to be a little bit longer. It's going to be 15 or 16 minutes. And that is so you can go get your book signed by the author. Has anyone purchased a book or brought a book in to be signed?
Uh-oh. You back?
Oh, you got something? Okay. Oh, then you're going to be first in line to go get it signed, and the rest of you are all going to rush out and buy the book at break.
There's more.
And then, oh, good. It's a little dark back there. It's always hard to see. And then there will be the opportunity for a second signing after the show, but we want to try to get as much done, and also the bookstore closes. So if you're going to buy a book, you're going to want to do it right after Dr. Weintraub's presentation. And for those of you on live stream, go to Amazon. I assume you can get it there, or the bookstore of your choice. And I know you're going to want to do that after you've met and heard David. So after that, we'll come back for a second half. And there are a couple of these I like a lot, except I'm going to have to lean in to see them. Oh, yes, how can I? Okay, there we go. Binary brouhaha. Blue Origin gets a little extra altitude, a tail of 2 Falcons, Jupiter's dozen. My favorite, you can read yourselves, is probably Blazar Neutrinos is the name of my new punk band, and which is a really good name. I think that came from you, Jared. Thank you very much for that one. That was great. And of course, Hakuna Matelescope. So we will, Andromeda's hostile takeover. We'll tell you what all of those stories mean as we go ahead. So let's start with our obligatory launch. And there we have, for those of you who like it, it looks so real, doesn't it? But indeed, we do have 4 launches. There was a very busy month. 1 Virgin Galactic, 2 SpaceX, and 1 Blue Origins. So here we just put them all together for you.
4,
and
3, 2, 1, ignition. Liftoff of Falcon 9.
So the SpaceX in the lower right corner was on a very foggy morning, so you didn't get to see much. But so we didn't just have 1 launch, we had 4 launches to launch off this program. So, of course, the commercial space program is really on a tear, doing wonderful, amazing things. And today, NASA announced the first crews to go on the first 2 commercial space transportation systems up to the International Space Station. So there's the Boeing Starliner, the SpaceX Dragon 2. By the end of the year, both will be tested in an uncrewed, the crew vehicle will be tested in an uncrewed version, and then next spring or early summer, we're going to send people up in those. So that's very, very exciting. As you can see, the individuals have been identified and named, and there they are, selected, and you can see the different members. On the left, these 2 are going in the Starliner, and these 2 are going to go in the SpaceX, the first ones. So those are very brave individuals going back to the days of the first one in a spacecraft to go try a new spacecraft. So that would be very exciting. And then also big NASA news coming up next week. We just want to alert you, get a couple headlines out of the way.
Yes, the Parker Solar Probe. So we've been looking forward to this, and we're launching August 11th, and it's a mission to the Sun, and we'll get as close as 4 million miles to the Sun and study the corona, the Sun's outer atmosphere. So this is going to be very exciting.
And what's the temperature difference between the sun and the before?
Sunward side is 2,500 Fahrenheit, and then the other side is just about 80 degrees. It has a 4.5-inch thick shield, which is shown there.
So how many engineers in this room right now? Yay, engineers, you rock. How many gonna be engineers? Any young folks thinking you might be an engineer? I mean, yay. Okay, I don't know who you pointed at, but yay. Oh, great, because you get to do cool things like figure that out. You know, let's fly to the sun and not have it melt. Okay. So speaking of melting, well, some of you know I wasn't here last time, and I was in Cuba, where I had no, and I guess you know that too, but anyway, I had no cell phone, no internet, no nothing, and I landed on U.S. soil and turned on my phone, and this is what I saw. So that was a welcome back. You all know that Griffith Observatory had a big fire last month. And so we just have a couple pictures to share. We love that one. This is if you're coming along Western Canyon Road, and in case you didn't recognize it, there's Matthew Burlando's thumb. Matthew's in the back. He's our engineer back there. Hi, Matthew. Thank you for your lovely thumb shot. Also, Natalie Vindovich, one of our other staff members, took this picture from nearly the same place. So it was a pretty, it happened like that. It was small, and then it was big. And here's a little movie of what it was like from the lawn. You might recognize David Reitzel standing there in the back. So it was a significant thing. We vacated and were closed for several days while the embers cooled down. I know some people are like, how come we had to stay closed? Well, it was, although it was contained, there were embers and flare-ups and hot spots. It was 300 degrees, temperature of 300 degrees Fahrenheit overnight. So completely unsafe. So yes, we kept it closed until it was safe for people to come. We're very grateful to the fire department, of course, who did amazing stunts to get it just, perfectly put out. There's their team. They were up here for several days, and the extent of the fire. And you can see in particular that right here, it jumps, there's the tunnel, and here it jumps over West Observatory Road, where some of you may park. So if you happen to be visiting the observatory that day and you paid for the parking spot, that was your thanks. I don't know if they got their money back. That's a really good question. I think they probably had bigger worries. Yeah, so then came the cleanup, and just to sort of show you the aftermath. Right now, if you drive through up the West Observatory, you'll see the charred hillside above where those cars were. And that's what the whole hillside looks like. So the lesson is you gotta be super careful. Sometimes visitors wonder why we prohibit smoking up here. That's why. So we did have planned a larger segment. Of course, there are wildfires throughout California, devastating wildfires, and often we cover them here, but we had so much, we didn't cover them. But we, earlier in the month when we thought we might, we had this already lined up for you. So we're going to go ahead and show it, because Yeah, because whenever there's bad news, you have to see something furry and cute to to make it all better. Okay, now you feel better about the fires. So, Tony, can you tell us a little bit about what's in the sky this month?
Yes. Well, actually, this is a great month for viewing planets because usually I send you, getting up at 3 in the morning to see planets, stuff like that. But now they're actually all up right after sunset. So let's go on ahead. We'll take you. The moon will point out the planets in this time. So if you get up, or if you are up at 9 o'clock at night, should be, if you're still awake at 9 o'clock at night, look to the southwest, in the west, you'll see Venus, the brightest planet, and the moon will be peeking up right next to it. Next night, the moon will be above Venus. Going on, the moon next approaches the planet Jupiter in the constellation Libra, the Scales. And keep going. The moon will keep moving off to the east, and on August 18th, it'll be kind of between the planets. So you'll see the moon, and then on either side of it, you'll have Jupiter and Venus to the right, and Saturn and Mars off to the left. And remember, the planets are the brightest things in the sky after the moon. So most of these planets are brighter than stars. Saturn is maybe like a bright star, but the other ones are actually quite a bit brighter than any stars. On the 20th, it passes Saturn, and finally Mars on the 22nd and 23rd. So if you pay attention to our weekly sky report, I'll remind you of all these dates. It's online on our website. Here's what you'd see if you have a telescope. Now, actually, you won't see quite this much on Venus. This is taken with an ultraviolet filter so that you can see the cloud details. But otherwise, the phase is visible, and Venus is about half lit right now through a telescope. Jupiter always has a lot of beautiful detail. You can see the dark belts, bright zones between them, and the orange red spot. It's pretty obvious.
Not the orange spot? The orange red spot.
Well, it's called the red spot. It's actually kind of pumpkin color, although it actually changes over time. Sometimes it is brick red, but currently it's more pumpkin, I would say. And in this picture, it looks kind of day-glow orange. But, Jupiter rotates every 10 hours, so you don't always see the red spot every time you look at it. Again, the sky report will tell you what days you can see it. Saturn is beautiful now. Although the rings aren't quite at their maximum opening, that was last year, they're still close to their maximum opening, and this is the best time to see it now if you want to see it through our telescopes on the lawn. All of August will be great for that. And finally, Mars, passed its close approach on Monday, and we'll probably be mentioning a little bit more about that later. Currently, there is a dust storm that's now settling. So as this picture shows, you can faintly see the dark markings on the planet through a telescope. It looks kind of like they've been painted over with a thin layer of paint. It's very hard to see the markings, but they are becoming more visible. Also, with that, I guess we're holding out hope that maybe we'll hear from Opportunity as the dust now is settling around it. Maybe the sun is shining bright enough for it to get power. So this is also a great month to see Mars. Even though it's past its closest approach, now it's visible in the evening. You don't have to stay up till 1 in the morning to see it. As the month goes on, it'll move into the evening sky. So in about a week, it'll be a regular part of our program with our telescopes here. Okay, now the moon is, what's that logo? I don't get it. Okay, explain. What's the logo? Devo.
They're from Akron.
Oh, I didn't know Devo was from Akron. Anyway, we are not men. We are Devo. Okay. Anyway, you'll notice that the moon is new on the 11th. This is good for a number of reasons. We'll go on ahead. There's a solar eclipse on the 11th. Now, we won't see that here. It's only visible, well, it's visible across northern Europe and northern Asia and Greenland, maybe a bit of Canada. We'll go on ahead. If you go to where it's maximum, where it's a sweltering part of northern Siberia, and this is actually a real picture from about a week ago. Poor polar bear there is getting some relief from the bright sunlight by that crescent sun. So about 70% of the sun will be covered from Siberia. So, okay. And in the morning sky, no more planets because, well, Mars is up until just before sunrise now. But all the planets have moved out of the morning sky. Go on ahead. But the exciting thing, and this is why the new moon on August 11th is good, is that the night after that is the height of the Perseid meteor shower. And to see meteors, you want to go out of the city. Around here, probably the nearest really great places like Joshua Tree National Park. Also, the moon's not out, so having a dark sky and a moon-free sky means you can see the maximum number of meteors. We expect a little over 1 per minute at its maximum, so about 70 per hour is what we're expecting this year.
And is that from a dark site?
That's from a dark site, and also it's after midnight, so you can see the meteors starting about 10 at night, but and they're nice and slow and sometimes very bright early in the evening, but they become faster and more numerous after midnight and just before dawn. So you can watch until about 4:40 in the morning, and then that's when you'll see the greatest number of them probably.
Great. So Tony mentioned about all 4 of those beautiful planets up. How many of you here tonight have gone out and been able to go, yes, 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 I've seen all 4? So it's totally easy to do, especially in some ways in a city where the light pollution is bad, because that means you can't see any of those other pesky stars that make it hard to identify them. They really stand out. And so we encourage you to do that. As Tony said, you have a couple weeks more. And it's kind of astonishing to just see them lined up all in a row. That's because they're all in the plane of the solar system. All of us are on that same sort of record disk orbits all rotating in roughly the same plane, and so they all look like they're lined up. And it's a beautiful sight, and I strongly encourage you to do it. We have, especially if you're up, well, late, but not too late, midnight, 11 o'clock, midnight, or later, it's almost impossible to miss the gorgeous Mars, because Mars is so orange and so bright, it really is impossible to miss. So I really hope you will do that. As Tony mentioned, it reached its closest approach to Earth just last Monday, and we had an event up here. How many of you were at this event? How many of you watched any of it on live stream? Okay, great. Well, it was a beautiful evening. This is sunset, people starting to get set up. Our own David Nakamoto, who's one of our staff, was setting up his telescope. And just to give you an idea, even with the dust storm, even with the low declination, that telescope that he's next to was able to get a picture like that. So pretty impressive. But if you think that telescope looks a little small, well, let's consider this larger telescope. And I wonder if we can recognize who might be, whose silhouette that is. And if you don't know what I'm talking about, look at the fellow behind the camera here with a hair sticking straight up. That's Jared, our friend and staff member. And so he was preparing for the live stream. We streamed it, 4 hours of it live from the roof of the observatory. We turned off that light and did everything. That was just during setup and takedown, but did everything with an infrared camera. So I'm going to show you a couple pictures from it, but they all have this black and white thing. But that is Mars and Saturn over the planetarium dome of the observatory. A shot, just a screen grab from our telecast or broadcast the other night. So it was an absolutely breathtakingly, magically beautiful evening, and we had a wonderful time. We had a lot of visitors from Jet Propulsion Laboratory. Rich Zurich is the head of the Mars exploration program, the chief scientist at NASA's JPL. So he's the guy, the top scientist dog, running the whole, okay, he's not a dog, but running the whole Mars science program there. So he was a wonderful guest. We enjoyed talking to him. We had Farah Alibay, who is an engineer on InSight, who is telling us about what it's like to try to engineer a spacecraft to land on Mars. And here, Carrie Bean and Ashwin Vasavada were there. They're from Opportunity and Curiosity, 2 rovers that are there now. So we had a lot of fun from NASA participation. We also had a special guest, and I had the joy of talking to Buzz Aldrin and turning around and looking at the moon with him. So that was kind of cool to be able to look at the moon with somebody who's been there. And then we also had Tim Russ and Andre Bormanis, both of whom have been on this show before, both avid amateur astronomers. Tim is Tuvok on Star Trek. We also had cast members and writers from The Expanse, and I understand last month from Cuba, I asked you how many of you love The Expanse, and I was told there weren't a lot of people, so okay, I'm just going to keep going then. And then the last of the evening, Tony and Blake Estes, who is one of our telescope demonstrators, was helping us that evening, and Blake got a couple gorgeous photographs here from Griffith Observatory. Beautiful picture of Mars, and then he used an infrared filter and got that picture of Mars. So really quite wonderful. And then bringing up Blake was last, second to last was the intrepid Dr. David Weintraub, who stayed up or got up for a 3:30 call-in from Nashville, Tennessee. So with that, I think I'd like to ask you, David, to come up and join us on stage, and let's welcome Dr. David Weintraub. So live and in person instead of on this Skype call. So it's such a pleasure to have you here.
Much better to be here.
Yes, I can imagine. So I asked David to join us even just a little bit before his presentation because we wanted to talk a little bit about a headline I'm sure you must have seen in the news because it's a big one. At Mars, not through a telescope, but from a spacecraft that was that's at Mars called Mars Express. It's a European orbiter around Mars, and it has an instrument on it that is actually part NASA, part European Space Agency, that does radar sounding. And what they found is groundbreaking. We've been looking for liquid water on Mars for a long, long, long time. And we know that there's water in the caps. We know that there's water in ice form under the surface. But we have not yet been able to find liquid water. So this new result is an interpretation of data that suggests that indeed there may be liquid water lake under the surface of Mars. If that's the case, that's really cool. The reason we care so much about liquid water, and I'm sure you're going to talk about this at length, is because liquid water is absolutely essential for life. You can't have life if you don't have liquid water, at least here on Earth. And you need some kind of liquid, and liquid water has a lot of amazing properties that make it just an essential ingredient for life. So we believe that if we're going to look for life as we know it, and we can always talk about life as we don't know it a little bit later this evening if you like, but if we're going to look for life as we know it, then we need to find a place where there is liquid water, and that's what makes this so important. So the spacecraft sent down radio pulses, and then they echo back. And as this little diagram tries to explain, they change depending on what they hit. They penetrate through the surface. It went through about 1.5 kilometers deep and gave a bright signature that people think could be a sign of liquid water. Here are the data. I'm sure you're looking at this and saying, oh yes, I see the liquid water. But this is the surface of Mars. So there's one reflection, because of course the radar just bounces right back. But then that which doesn't bounce back penetrates through and bounces back more when it hits a change from water to rock, ice to rock, or rock to water, ice to water. And in fact, the brightest reflections are associated with reflections to water. So that is what we're seeing, what they're seeing. Now, these data were taken from 2012 to 2015, but there was an automatic software program that was averaging pixels and kind of working with the data and delivering a semi-reduced data set, and that was obscuring this. So they went back and they said, let's take a look at the raw data. And when they looked at the raw, unprocessed, that hadn't gone through this sort of, average pixel averaging program, this is what they saw. Now, what's exciting about it is that they saw it in several passes. Each one of these streaks represents a different flight of Mars Express over Mars, taking those measurements. So you can see that at this brightest spot here, there's 1, 2, 3, 4, 5, 6. There are several different independent measurements that all showed the same bright reflection signature. So their interpretation is, the best explanation, and the brightness of it, they could do a numerical. They did some calculations trying to simulate, could it be anything else other than water? And their simulations and their conclusion was, no, it's probably liquid water. So that's a very exciting thing. Here on Earth, we also see subsurface lakes under the ice in Antarctica. This is a little picture of a lake, little diagram showing that we've drilled down almost all the way to Lake Vostok and a couple other places in Antarctica. But we like this one a little bit better. But the reason this is kind of super exciting is that in Lake Vostok and in the ice just adjacent to it, we have found creatures that live, in freezing temperatures. The water is kept liquid because of the pressure and because of the salts, like using antifreeze. And so it's still liquid even though it's below freezing, and there are creatures that live down there. Now, the conditions on Mars are more extreme, saltier and colder, but still, it's very tantalizing to the idea that there could be life on Mars. So I'm going to begin, David, by asking you, what do you think of that? Do you think it's real?
I think it's real, but I think it's probably real. I would like a little bit more information, but it looks very certain. And what I would caution everybody to recognize is that we have not discovered life on Mars, but this is an incredibly important discovery, because if I were designing a mission to Mars now, I would want to design a mission that could drill a core to sample the water in that subsurface lake, because it is certainly one of the best possible places to search for life on Mars.
So, and there are discussions about instruments on future missions that can go verify this and look at other frequencies and try to get additional information about it. So, yeah, I'm surprised to hear you say that you would go right on in and drill. I was wondering what you were going to say about that. All right.
I said if I were designing a mission to do that.
Get Bruce Willis and a few drills and let's go. So let me give that to you. And so as you are all aware, David, who has written several books, has written a book called Life on Mars, What to Know Before We Go. So David, will you tell us a little bit about your book?
I will. Do you need me to say confined to this chair?
Confined? No, you don't have to be confined.
Wander?
You can wander. It's a little hard on the camera guy, but he'll do it.
Try not to wander too far.
Hey,
but I'm
live
better
stream
off
folks, we'll do our best.
on my feet. So what I want to tell you about is what you should be thinking about Mars right now, because I have a few slides to illustrate an important idea, and that is that we're on our way to Mars. I find that absolutely incredible. But we have several folks, Elon Musk and his SpaceX project. Elon Musk wants to go to Mars. More than anybody else, Elon Musk wants to go to Mars. And you saw a SpaceX launch earlier. Elon Musk plans to have his rockets ready by 2022 to take cargo to Mars, by 2024 to take astronauts to Mars. SpaceX has achieved almost all of its goals on time. So I think we have no reason to doubt that it is possible that we will have humans on the surface of Mars by 2024. Wow. That actually scares me. Okay? Now, something you should recognize about the SpaceX project is that SpaceX may have the ability to get astronauts to Mars. They do not yet have the ability to bring anyone home from Mars. They do not yet have the ability to find the water they need to survive on Mars or to protect themselves from harsh radiation from space to survive on Mars. So the first astronauts to Mars, they may be on a one-way trip that they may not return from. That's an important thing for you to think about. But Elon Musk is not the only player in this game. Jeff Bezos and his Blue Origin project. Blue Origin wants to go to Mars, not immediately. Jeff Bezos wants to put humans to work in space around the Earth and then go to the moon and then go to Mars, but he does plan to go to Mars. I didn't know that slide was there. That's pretty good. I'm not going to Mars anytime soon, but we can talk about that. But get the book. All right. NASA, as you know, NASA is planning to go to Mars in the 2030s. NASA's plans right now to go to Mars do not include immediately setting foot on Mars, but going to the Mars system, because if you go to orbit around Mars, you can actually bring your astronauts home. And since you are paying your tax dollars for the NASA program, you probably want your astronauts to have a chance to come home again. So that's the way they're playing right now. The United Arab Emirates has announced they want to build a city on Mars by 2117. They do not have rockets yet, but they do have plans to build a city on Mars. And the Mars One group out of the Netherlands already has an astronaut corps. They do not have rockets either. They're planning to buy off-the-shelf components from Boeing or Lockheed or someone else, but they're planning to go to Mars. So there are at least 5 different groups planning to go to Mars. Whether we get there in the 2020s or the 2030s or the 2040s or the 2050s, there are a lot of folks in this room who are likely to be alive when humans set foot on Mars. And that is absolutely incredible. Whether it's a good idea or not, that's a different question. And that's part of what I want to talk to you about. So let me take you back a little bit. Early in the early days of telescopes, Christian Huygens made a major discovery about Mars, and that is that it rotates in 24 hours. It's actually about 24 hours and 39 minutes. We got that corrected later on. But this is his original sketch of Mars. It's not as pretty as the pictures you saw of Mars earlier. In the 1660s, you had to actually draw a sketch of Mars with your hand. But this is what he saw, and what he saw on the surface of Mars, we can actually identify now what he was looking at. But by 1670, we knew that Mars rotated in 24 hours. There is another planet you know about that rotates in about 24 hours? Anybody identify that planet? Never heard of it. All right. The next big discovery about Mars, and you've already seen this in some images, is that Mars has polar caps. There's another planet you know about that has polar caps. And by the end of the 18th century, William Herschel discovered that Mars's rotation axis is tilted about 25 degrees from the direction of the sun, which means Mars has seasons. Now, if you put all that together, by the turn of the centuries, from the 1700s to the 1800s, what did we know about Mars? Mars had a 24-hour day just like the Earth. It has a year with about twice as many days as the Earth, but similar to the Earth. It has polar caps, it has seasons, it has a thin atmosphere, it has a solid surface. Astronomers had come to the conclusion that Mars is an Earth-like planet. It might be another Earth. What then happened in the 19th century is astronomers really turned Mars into another Earth. They made a lot of observations that were over-interpreted, overzealously interpreted perhaps, but we created an idea that there could be life on Mars. These two folks are pretty important. In the 1830s, these two German astronomers spent a decade mapping the surface of Mars, and they came up with this map. This is the map of the southern hemisphere, and the thing marked with the letter A at the left-hand side, that's what Huygens was looking at in the 1650s and 1660s. But what they concluded is that the dark areas they saw on Mars were oceans, and the light areas were continents, because Mars is just like the Earth. So the next round of mapping of Mars understood Mars as being like the Earth, where the dark areas are ocean and the light areas are continents. So we get maps like this. This is from 1880. But in this map, you start seeing features in the maps of Mars where they're labeled as continents and oceans. We have the Dawes Ocean, the Dawes Continent. He got lots of stuff named after him. The Herschel Continent. Almost none of these names survive till today. But by the 1880s, we had this image that Mars had continents and Mars has oceans. Mars does not have continents like the Earth. Mars does not have oceans like the Earth. But this has colored our thinking about Mars since that time. This also was the first appearance of the word canal on Mars. And canals then got a robust but bad history on Mars. The canals don't exist, but again, the idea of canals became part of our thinking about Mars. What I want to do for the rest of my time is talk to you about what I think is the most important set of discoveries on Mars in terms of understanding whether there is life on Mars or is not life on Mars. And that has to do with methane. And the methane era, the scientific era of studying methane, began in 1969 when we launched the Mariner 7 mission. Launched on March 27th, got to Mars on August 5th. You need to remember the date, August 5th. There will be a quiz in a few moments. Okay? Because 2 days later, on August 7th, NASA held a press conference. And the press conference was to announce the results from that work. Now, what you just saw from the measurements from Mars Observer,
Mars Express.
Mars Express, for the lake on Mars, data from 2012 to 2015 is now 3 years later. They've been analyzing that data for years. That's why I think we can probably expect that they got the right answer. August 7th, that's 2 days after the spacecraft flew past Mars. They had a press conference to announce the results. Now, George Pimentel, who's pictured here, was the principal investigator on the instrument on that spacecraft called the infrared spectrometer. George Pimentel is one of the giants of 20th century chemistry. There's a statue on the UC Berkeley campus of George Pimentel. He's a great scientist. At that press conference, he said, "We are confident that we have detected gaseous methane and gaseous ammonia between approximately 61 degrees and 76 degrees south latitudes on Mars." Newspapers on August 9th said, "Two gases associated with life found on Mars near the polar cap. Mariner hints life on Mars." The world suddenly knew we'd found gases on Mars that almost certainly tell us there is life on Mars. About a month later, another quote from that same press conference from Kenneth Kerr, who was on the spectrometer team. Kenneth Kerr said, "I have no clue as to the origin of these gases." He should have stopped right there, okay? Because up to that point, he was correct, okay? But he continued, "But if the readings are true, and I believe they are, we have to face the possibility that they could be of biological origin. Methane means life." All right, so September 11th, another news conference. George Pimentel says, "The spectral features previously attributed to methane and ammonia were, in fact, caused by frozen carbon dioxide, dry ice." He continued, "The new discovery removed one of the final hopes scientists held of finding life on the planets." Not really. Okay. "The fact that carbon dioxide can mimic the behavior of methane and ammonia was just a cruel coincidence." Not really. Okay? If they had spent a couple months, let alone years, analyzing that data, there never would have been those headlines in the newspapers saying, "We probably found hints of life on Mars." But astronomers, I think, want to find life on Mars. Laura asked me this the other day. "Do you want to find life on Mars?" I think it'd be pretty neat. Okay? I think it'd be phenomenal. But it's the wrong question. But I think the idea that astronomers have wanted to find life on Mars have colored our interpretations of our measurements for a long time and led us in wrong directions, and this is one of them. But the methane idea is a good one, and here's why. A cow eats grass. The grass goes into one of its many stomachs. The bacteria digest it, and it ferments, and it produces hydrogen gas and carbon dioxide gas. And then in another stomach, there are methanogens that turn those gases into methane, and the methane comes out of the cow in both directions. Okay? And the atmosphere of the Earth fills up with methane. So this pie chart tells you where the methane in the Earth's atmosphere comes from. We have rice paddies where there are bacteria in the soil producing methane. We have landfills where there's bacteria producing methane. We have ruminant livestock like cows and sheep and llamas and camels that produce methane. We have termites that produce methane. 100% of the methane in the Earth's atmosphere comes from biology. How much methane is there? I've got a number in the top corner for you, about 1,800 parts per billion in the Earth's atmosphere. So if you had 1 billion atoms or molecules from the Earth's atmosphere, 1,800 of them would be methane. That's a lot of methane. If you were on the other side of the Milky Way galaxy and you could point a telescope at the Earth, you could detect that methane in the Earth's atmosphere. It would be easy to detect that methane. And there's another set of numbers up there on this slide. The methane in the Earth's atmosphere can survive for about 12 years. In our environment, with all the oxygen in the atmosphere, with the ultraviolet light coming in from the sun, the methane gets destroyed in only 12 years. So the presence of methane in the Earth's atmosphere, simultaneously with the presence of oxygen in the Earth's atmosphere, tells you that there is something on the Earth producing the methane. And on the Earth, that's life. There are no other sources that can produce that volume of methane. If you had that telescope on the other side of the Milky Way, you could prove that life exists on Earth by measuring the presence of methane gas in the Earth's atmosphere. That is what has drawn astronomers to study methane in the atmosphere of Mars. That's what the Mariner 7 scientists were looking for half a century ago. Unfortunately, they found carbon dioxide instead. But for the last 50 years, we have been searching for methane in Mars's atmosphere. In Mars's atmosphere, the methane can last a bit longer, 300 years. And that means if you find methane in Mars's atmosphere today, it did not exist 1,000 years ago, or 1,000,000 years ago, or 1,000,000,000 years ago. Something is making the methane. Could be life. So search for methane. It's an incredibly good, powerful idea for understanding life on Mars. Now, if you're using a telescope on the Earth, you're looking through the Earth's atmosphere, you're looking through Mars's atmosphere. It's very difficult to make these measurements. So while people have tried to do that, we have sent a spacecraft to Mars to measure methane on the surface of Mars, in the atmosphere of Mars. So the Curiosity rover landed in 2012. This is a selfie by the Curiosity rover. In 2015, the Curiosity rover team announced that they had, in 2013, excuse me, they announced that they had not detected any methane on Mars. They had spent 2 years making these measurements, and the amount of methane they found was less than 1/5 of 1 part per billion. Now, that doesn't mean they'd found 1/5 of 1 part per billion. It means they hadn't found any methane. They could not detect methane, which suggested that life is not producing methane on Mars. However, in December of 2015, they made a new announcement. And in that announcement, they said that in January and February of 2014, they had detected methane. The amount of methane was 7 parts per billion, not 1,800 parts per billion, but a significant amount of methane. And there is nobody who disputes that measurement. That's an accurate measurement. They detected methane on Mars. The question is, where does it come from? So I've got a cartoon here for you with some possible sources of production for the methane. In the top left-hand corner, you have ultraviolet light coming in from the sun. It reacts with organic molecules in the soil. That's another big discovery. Earlier this year, we had an announcement that organic molecules had been discovered in the soil of Mars. An organic molecule is a molecule that has carbon in the molecule. It's not life, but life on Earth is based on carbon chemistry. That's why it's called organic. Finding organic molecules on the surface of Mars suggests the possibility that life could be responsible for putting the organics in there, but it doesn't prove life is there. But if there are organics in the surface soil, and we now know there are, and ultraviolet light comes in, the reactions between the two can produce methane. That wouldn't mean life is produced by methane in that situation, but methane could have produced those organics. Another possibility on the bottom right is olivine rocks in the soil react with water. We know there's water. The water in the olivine produce methane that bubbles out of the ground. Another possibility on the top right is that methanol and formaldehyde react with sunlight and they get stirred up by dust devils on Mars and produce methane. And the last one in the bottom left corner would be microbes under the soil. Microbes in those lakes underneath the surface. None of these processes are proven to exist on Mars. All of these processes could produce the methane that we're seeing. Now, one of the oddities about those methane measurements is that they disappeared. After February of 2014, no more methane. The Curiosity team is seeing methane, and it actually is a very small amount of methane, less than 1 part per billion, that goes up to 2 parts and back down again, that appears to be seasonal. That amount of methane could be produced by non-biological processes, but it also could be produced by biology. We just don't know yet. So,
Question?
yes,
Are the
Laura.
seasonal, would the other mechanisms for creating methane also be seasonal?
The other mechanisms probably also would be seasonal, so I don't think that
tells
helps
us
us one way or
anything,
the
yeah.
other. Okay. What we have to do is keep measuring the methane to find out. But the presence of any methane on Mars means the possibility that life exists on Mars today, it's out there. It could really exist. Now, there's one other plausible source for this methane, and that is that we brought it with us from Florida. This may be the most expensive experiment ever designed that proved life exists on Earth. That spacecraft sitting on the ground in Mars absorbed methane from the atmosphere in Florida. That methane went with them to Mars. The scientists on the Curiosity team know that. They have tried to account for that in their measurements, but it is possible that they have discovered terrestrial methane rather than Martian methane. It's hard to figure. Science is hard. Okay? All right. So this evidence puts out there for us the possibility that life exists on Mars today. It doesn't prove it exists, and I think the odds from this are against it because there are other possible sources, but this could be evidence of life on Mars, and that's pretty incredible. If life could exist on Mars, and this is where Laura was calling me out earlier, we have an interesting question to ponder. And that's why I want to take you somewhere else. So Europa is a moon of Jupiter. Europa is a warm moon of Jupiter. The tides heat up Europa. The rock has settled to the center. The water has bubbled up to the surface because it's lighter. And this is a cartoon sketch of the inside of Europa, where you have an icy crest and a subsurface ocean. And scientists are very, very certain that Europa has this subsurface global ocean. Beneath the surface of Europa is liquid water. And it's warm. It doesn't get sunlight, but we know there's life on Earth in the deep ocean where there's no sunlight. Life could exist in these oceans. It has the water, it has the heat source, you've got the magnesium and the calcium and the carbon and everything else you need to build up life. We have seen geysers erupting from the surface of Europa, water geysers coming out. Those geysers could have microbes in them, being spewed out from these subsurface oceans. I want to take you somewhere else. Enceladus is a moon of Saturn. Enceladus also is warm. We have also seen water ice geysers erupting from the surface of Enceladus. Here it's even more spectacular. Those geysers also could have bacteria or microbes being erupted into space. Europa and Enceladus are two places that planetary astronomers desperately want to go back to. And there's already a Europa mission in the planning stages. Why do we want to go back there? Because those are two places where life could exist in our solar system. In September last year, almost a year ago, NASA had a mission, the Cassini mission, that was in orbit around Saturn. And the Cassini mission was running out of fuel. Anybody know what we did with the Cassini mission? Yeah. Crashed it into Saturn. We used the last amount of fuel to turn it so it would crash into Saturn. Why did we do that? Because we do not want to take the risk that that spacecraft could crash into Enceladus and contaminate Enceladus, because life might exist on Enceladus. A few years back, we had a mission orbiting Jupiter that was running out of fuel. What did we do? We targeted that mission to crash into Jupiter where it would burn up, so that in 10 years or 1,000 years or in 1,000,000 years, it could not possibly crash into Europa, because we do not want to contaminate Europa, because life might exist on Europa. And where is the closest place in the solar system, the closest place in the entire universe where life might exist? Mars. Mars is the closest place. And we know life could exist there. We've found a lot of water. There's a lot of water on the polar caps. It's frozen. We now know there's a salty lake beneath the south polar caps. There's permafrost. Life could exist on Mars. The methane might be evidence of that life. Yet we're not trying to protect Mars in the same way we're trying to protect Europa or Enceladus. I actually find that puzzling and disturbing. Okay? We may have footprints on Mars in 6 years. Should we be doing that? I don't have an answer to that question, but I think you should be thinking about that question. What do we need to know before we go to Mars? I think we need to know whether there's life there. I think we can learn an awful lot about the possibility of life on Mars robotically before we send astronauts to set foot on the surface of Mars. And if there is life on Mars, there are 3 possibilities. One possibility is that life on Mars is DNA-based. If life on Mars is DNA-based, the possibility that life like us came into existence on another planet right next door independently is 0. If life on Mars is DNA-based, then life got started on either Earth or Mars, and an asteroid hit one of the planets and splashed a rock to the other planet and transported life from one planet to the other. And almost certainly it would have been a splash that took a rock from Mars to Earth, because for all sorts of reasons that's a whole lot easier, which means we're descended from Martians. We're Martians. That is a possibility. A second possibility is that life on Mars is not DNA-based, in which case we would know that on 2 planets right next door to each other around the same common star, life came into existence independently. That would be incredible to know. If life exists on Mars and we go to Mars and we contaminate Mars, and then we find the life on Mars, we may never know whether we're descended from Martians or not. We might never know whether the life we find on Mars is just contamination from the Earth. We also run the risk of destroying the life on Mars. We have a, I won't say proud history, but a lengthy history on this planet of human colonists moving from one part of the planet to the other and wiping out a great deal of the life on the planet that didn't previously have exposure to humanity. The chances of us doing that on Mars, I would say, are pretty good. Which means if there's life on Mars, we run the risk of wiping out the independent biology of an entire planet. Do we want to do that? So I would contend that one of the things we should be talking about as we race to set humans on Mars is whether this is actually a good idea before we know the answer to the question, is there life on Mars? We can probably, in a few decades, certainly in a century, with the exploration we can do robotically, we can determine to a great deal of certainty whether life exists on Mars. We can drill down to that lake. Now that exposes Mars a little bit to contamination, but I think we probably should take that risk. We can send rovers that can explore and find caves and go inside the caves to look for life on Mars. We can turn over rocks to look for life on Mars. We can do all of that without sending humans to Mars. Because when you send humans to Mars, you need to send life support systems, cargo, habitats, food. When we send humans to Mars, we will contaminate Mars irretrievably. But robotically, we can probably figure out whether Mars is inhabited already without contaminating Mars too much. And if Mars is sterile, let's go to Mars. But if Mars has life, perhaps we should talk about whether Mars belongs to the Martians, or whether we have some inalienable right to simply colonize another planet. So I'll leave you with that. I'd love to take some questions.
I have a question.
Please.
And feel free to have a seat if you like. If we, no, because
It's a
now I
hot
want to talk
seat.
to you.
It's a really hot seat.
Oh. No, this is a science question. Is it possible to isolate zones where, you know, if we do go, and the footprint's going to be pretty small because we're not going to be roving around or anything, of where humans land, will that necessarily, I mean, are there enough transport mechanisms and so forth where just our presence on Mars will mess the whole thing up?
Can we land in a little spot and not contaminate the rest of the planet? No. Mars has global dust storms. Okay? The atmosphere is thin, and anything that we place in the air there, it's going to spread across the planet within 2 years, because it has these global dust storms every 2 years. So I don't think there's any way for us to not contaminate Mars once we try to put humans there.
Yeah.
Would we not have already considered the contamination of Mars from the probes that we've sent, like Viking and other ones that have, and the Beagle 2 that have already landed on the surface that may have already had microbes on it already?
Have we already contaminated Mars with the probes who've already landed on the surface of Mars? Yes, we have, but not at the level that we would with human footprints on Mars. The Curiosity rover on Mars, almost certainly some terrestrial bacteria went with the Curiosity rover to Mars. No matter how well we try to sterilize these spacecraft, the chances of a few bacteria hitching a ride are pretty good. But the atmosphere of Mars is very thin, and the radiation at the surface of Mars is very harsh. So those creatures that might get out of the spacecraft probably will be sterilized very quickly and won't spread across Mars. The stuff that stays inside the spacecraft is inside the spacecraft. So I don't think we've contaminated Mars in a significant way yet. Again, I would say that because of all the resources we need to place on Mars in order for humans to survive, you know, SpaceX is talking about dropping dozens, even hundreds of payloads onto the surface with 3D printers and food and everything else, the habitats these colonists will need. That's a lot of stuff. And you can't sterilize all that stuff, and that stuff will spread.
Yes, back, all the way in the back.
You said DNA will DNA independently rise on Mars and Earth? Why couldn't it independently rise on other?
Why couldn't DNA arise independently? It could, but I think the chances that the same chemical design for life would arise independently and identically, I think that's incredibly small. I think if life arises independently, the chances are it will find a different mechanism. It may still be carbon-based, that's probably likely, but for it to be DNA, I just think that is very hard to sell that idea.
Yes.
Yes, I was wondering if people like yourselves are kind of putting the word out to folks like Elon Musk and Jeff Bezos to consider staying their horses a little bit before more information is found out.
Are people like me putting the word out? By showing up here, I am. Elon Musk has not called me up to talk about this yet. Okay? Jeff Bezos has not called me up to talk about this yet. There are people talking about it, but I think it's in the whisper stage, if anything. I think humanity collectively desperately wants to go to Mars. Do I think my talking about it is going to slow us down? Probably not. But I do think we ought to be talking about it. I think the chances of slowing us down are very, very small, but they're not zero. And I think we could wait 30 years. That will disappoint some people, but that would be enough time, I think, to determine with a great deal of certainty whether Mars is sterile.
So let me ask you a question I asked you on the live stream, but then said you don't have to answer it now, answer it Friday, which is how could we possibly do that? I mean, there is no single global government. There are many entities, different nations, different corporations, all with plans, as you pointed out in your first few slides. So how could we even effectively, or would it have to be?
I think stopping our race to Mars would be extremely difficult at the moment. It would have to be an international agreement, and we're not very good at following or enforcing or agreeing to anything international. But we would certainly have to do that. We do have a very few examples where we've gotten this sort of thing right. The ozone hole, closing the ozone hole, stopping destroying the ozone layer, that was an international protocol, an international agreement. We decided to do it, we did it. We're not doing so well with global warming. But we did succeed with the ozone problem. That shows we can succeed. Now, if the international community agrees to put the brakes on, there could be some entrepreneur that will build a rocket in a cave on an island in the Pacific Ocean and go to Mars. And you couldn't prevent that because being able to launch rockets into space is almost easy now. It's expensive, but lots of people have figured out how to do it.
So is there any international law in place right now that prohibits or requires a level of certification or review or approvals to do this, or is that...
To launch a rocket or to go to Mars?
No, to go to Mars.
I don't believe there's any...
Well, that would require launching a rocket, of course, but...
I don't think there's any international law or national law. There's no United States law that says an individual citizen can't build a rocket and go to Mars, right? Perhaps because no one's thought to enact that law. Okay? But to my knowledge, there's no law in any country that says you can't decide to go to Mars and go there. But since it would take a few $100 billion to put together a program to get a rocket and astronauts to Mars, this isn't something that very many individuals could pull off at the moment. So I don't think we have to worry about very many entrepreneurs doing this on their own. But legally, I think it's possible.
Yes, we have time. I think so I'm going to kind of go around.
The groundwater, is it more than 10 meters down? And what month was your book published?
The book was published this May. So it's been out for 4 months or so. The groundwater just discovered, the lake underneath the South Pole, that's about a mile deep?
Yes,
Okay.
1.5 kilometers deep, yep.
So it's not very accessible. We have the ability, just like we have the ability to drill cores in the Gulf of Mexico, we can drill down to it, but it's not easily accessible water.
How about groundwater that's closer to the surface?
There's no liquid water that's been found close to the surface. There's permafrost that's been found, there's ice that's been found, but no liquid water reservoirs that have been found closer to the surface.
There was a question up there, yes.
So other than sort of tampering with the evidence, let's call it, can you help me understand what the consequences are of contaminating Mars?
If Mars is sterile, there are no consequences. If Mars has active biology today, then the main consequence is the risk of wiping out Martian life. The next consequence is simply a scientific one of interest to me, which would be discovering whether life on Mars is truly independent of life on Earth, or we are descendants of Martian life. And if we contaminate Mars and we find DNA-based life, we won't know whether that's Martian or contaminant.
Yeah, Tony.
Can you say anything about reconsidering the Viking results? And maybe recalling what those were.
Reconsidering the Viking results.
Yeah.
There's a whole chapter in the book. You can read about it. That's great. Okay? That's a short and sweet answer. But the Viking results made some discoveries that a very few people think might be evidence of life on Mars. Very few. Okay? Those very few people still think there might be evidence for life on Mars. But most scientists think the Viking evidence does not support life on Mars.
So 3 more questions. There, and I'm going to take the last one. Oh, I didn't see you up there. Okay, 4 more. 1, 2, 3, finish with me. Yeah.
Assuming that there was liquid water, do you have any theories as to how that would
gone down to that level?
Mars just started with a lot of water, just like the Earth. Mars was a water-rich planet. The big question for NASA for the last 25 years in studying Mars is to look for the water. And we found lots of water. We also found lots of evidence that some of Mars's water has escaped to space. So Mars may have lost 85% of the water it started with, or it may still have most of that water underground. Mars still is a water-rich planet. So the question simply is, where's the water hiding that's still in Mars? Mars is cold. So Mars can't have lots of lakes on the surface. They'd be frozen. And we don't see any evidence of lakes on the surface anyway. But how could the water get down there? It just was there in the first place. Mars had water. It didn't have to find the water. Comets can also bring water to a planet, and that may be one source of both the Earth's water and Mars's water. But Mars is and was a water-rich planet.
Yes.
If there was more than one bacteria in Mars, wouldn't there be like 1,000 lives on Mars?
If there's more than one bacterium on Mars, and what was the second part of that?
Wouldn't there be more life on Mars?
If you find even one bacterium, there must be a lot of life. The chances of us just stumbling across one place with life and being lucky because the rest of the planet is sterile is pretty small. So if you find life anywhere, that probably means there's lots of life on Mars. But almost certainly, any life on Mars is hiding beneath the surface. The surface itself is sterile because of the radiation from space. But inside caves, in permafrost, in lakes beneath the surface, anywhere on the planet, you can find life. And if you found it anywhere, then I'd be willing to bet it's everywhere.
And I would add to that that one of the distinguishing characteristics of life is that it reproduces. So it would be very unusual to have just one. Second to last.
So if we found that there was DNA-based life on Mars, would you be able to determine whether it is recently diverging or diverging 3 billion years ago from the strains on Earth just by comparing the sequences?
If we found DNA-based life on Mars, could you tell whether it diverged from life on Earth a few billion years ago or more recently? I'm not a biologist, so I couldn't answer that question, but I would think you could. You could do sequencing of the DNA and see how divergent it is from modern and ancient species of life on Earth and try to figure that out.
That would eliminate the contamination problem then.
You might be able to do that.
So I'm going to ask my last question, and I'm going to ask it in general and ask everyone to give it some thought, because in a minute we're going to turn off the lights and look at pretty pictures, and you can mull this. But I'm going to ask it of you specifically, and then I want to know your personal feelings about the answer to this question that you said you're not going to answer. Because, you don't have to represent, just your own personal feelings about it. And that is, and then I asked you this the other night, bacterium, schmacterium, who cares? They're little, they don't have brains. Why do we care
Who cares about
bacteria?
You're full of bacteria. Now I have, I think, 10 pounds of bacteria inside my body. They're part of us. If a bacterium exists, then the possibility exists that bacteria can evolve into more advanced forms of life. So even though that has happened already on Earth, it took a long time. It was hard. If life exists on Mars now, even if they're microscopic life forms, the possibility exists that those bacteria someday might evolve into more advanced life forms. But I actually think that doesn't matter. I think if they exist at all, that's what matters, that it's life. And if it's life that's independent, and again, we don't know if there's life, and we don't know if it would be independent of life on Earth, but if there is biology on Mars that is independent of life on Earth, I think discovering that would be one of the most incredible discoveries we have ever made, if not the most incredible discovery we've ever made. And that would teach us that life is probably abundant in the universe. If life can exist independently on 2 planets in the same solar system, then life is probably easy. The possibility of throwing away the chance to learn the answer to that question when the planet is right next door, I think is foolish. It's right there. We can find out. So it's not the bacterium itself that I care about, it's the scientific answer that comes from the bacterium. But if it's there, I actually want to care about the bacteria on Mars. I think they deserve their own planet.
Quick poll. How many of you think we shouldn't go there? It's the bacteria's planet, and we shouldn't disturb them? And how many of you say, to heck with those bacteria, we need to go to Mars and get a second home? Okay? No, I was just curious. It's a good debate. And, you know, we're about to take break, so you can duke it out upstairs. Or you can go buy the book and have more food for thought and have Dr. Weintraub sign it. And then just before saying goodbye to Dr. Weintraub, I do want to mention, since you mentioned Europa and Europa Clipper, that a month from now, the next All Space Considered, Dr. Robert Poplardo, who is at Jet Propulsion Laboratory and the project scientist for the mission that's going to Europa that he just mentioned, he will be our guest. So we hope you'll come back and hear about going to contaminate that planet, because, you know, it's a moon, but, you know, it's a human solar system, I guess. So I just want to say thank you to Dr. Weintraub for coming. I didn't mention at the beginning, but he and I have known each other for a long time. I know. I started to just see the word forming. No, I'm not going to say the number. A long time. We went to undergraduate college together and did all of our physics and astronomy classes and sat next to each other trying to. Well, there's a break.
Survive.
There's a break video you'll see of somebody listening to a math lecture, and that might have been the two of us during some of those lectures. But anyway, it is just a real joy to see you again and have you visit us and share your provocative ideas with this audience. So in a moment, he's going to go upstairs and get ready for the book signing. We always end the first half of All Space Considered by turning off the lights and looking at pretty pictures and just enjoying them for their pure aesthetic beauty. So we'll end as we always have in that way, and as we always do, we will sign off on the live stream just because we need to move on to other things, and we thank you for tuning in. This will be archived, so you will be able to share it and get excerpts of it on our YouTube channel. So, hey, check us out on our YouTube channel, our live stream channel, our Twitter feed, All Space Considered is the name, and our new Facebook page. We have a new Facebook page, and yeah, so if you're on Facebook, you can now like us or follow us or deal with us or whatever it is you do on Facebook. So with that, we'd like to thank you very much for coming.